What is application of integration? The basic idea of integral in calculus is finding the area under a curve. The area between two graphs can be evaluated by calculating the difference between the integrals of the two functions. Integration can be thought of as measuring the area under a curve defined by fx between 2 points.
Why we use integration? Integration is a fundamental operation of calculus and serves as a tool to solve problems in mathematics and physics involving the area of an arbitrary shape, the length of a curve, and the volume of a solid, among others. Example: how calculus used in daily life is in electrical engineering. Integration used to determine the exact length of power cable needed to connect two substations, which are miles away from each other. Problem statements: a tank of water is 15 feet in length and has a cross arrow looking like symmetrical triangle with side 2 feet in length. Purpose of the triangle focuses straightforwardly down. The tank is loaded up with water to a depth of 9 inches. Decide the measure of work expected to pump the entirety of the water to the highest point of the tank. Expect that the weight of the water is 62 lb.
The bottom point of tank we define as x equal to 0. The height of the water in the tank is x equal to 9 per 12. Then we simplify, we become 3 per 4 feet. So the interval will become 0, 3 per 4. Below is the sketch of the tank to help us visualize the water tank from the direct front. After we have visualized the full water tank, then we can get the front visual sketch of the water tank as below. We included the height in the above sketch, and this helped us to get some basic right triangle. So here we get cross-section sketch. Because it is equilateral triangle, each of the interior angles of the triangle must be theta per 3 and length of each side is 2. Each half of the triangle identical the right triangle, and we use trigonometry function to determine the height of the triangle. We use cosine. After determining the height, next we need the volume of the box of water by approximate the volume of water in the I subinterval. Approximate volume is the volume of a box, and we know that the volume for I subinterval would be from the cross-section sketch with the red strip in step 1. We see that we have two similar triangles. Since these two triangles are similar, the following two ratio must be equal to Combine that into the volume formula. We have next, we find how much force required to overcome the force of gravity that is needed on the water in the I subinterval. Next, we find how much force required to overcome the force of gravity that is needed on the water in the I subinterval. So the answer is last but not least, we need the amount of work required to raise the volume of water in the I subinterval to the top of the tank. Finally, the total amount of work to raise all the water to the top of the tank is approximately the sums of all the Wi for I equal to 1, 2 into n. The exact work required is then found by letting n equal to infinity. Then we find the defined integral. The work required to pump all the water to the top is. Then we calculate and simplify. The final answer for the question is 372.112 feet.
Overall conclusion of the question. As a conclusion, this question is about how we can determine the amount of work required to move an object subject to a force over a given distance. Integration can help us to solve many types of real-world problems. Acknowledgement. Thank you to our group member, Muhammad Sharif, Muhammad Haziq, and Kamila for effort and cooperation in finishing this assessment. We also sincerely thank you our lecturer, Dr. Liu Chin-ying, for the guidance and encouragement in finishing this assessment and teaching us in this course for this SEM.